stay blah, 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 blah. Oh, loud, huh? Is that better? Is that better? Is that better? Maddie? Louder? Louder. As somebody said the other day, you don't need a mic, Mr. Gins. Okay. There we go. Recording is down. So we got to keep good pace. Here we have it. And we want to find the area bound between these two curves. And if you notice, they don't give you any of the points of intersection. So first of all, do you know what the graph of x to the fourth looks like? If it's x to the fourth with a bunch of stuff after it, then it looks, like a W. But in this case, it is just x to the fourth, so it's going to look like this. It's a parabola that's maybe a little bit wider at the bottom, and then more up and down at the top. Okay. And then we have a y equals 2x squared minus 1. What does that look like? Parabola shifted down 1 unit. And what's interesting is, how does this parabola, how does the shape go? So I'll draw a couple of them. Does it look like that? Does it like cross, a couple times? Or maybe it goes wide on the outside. Or maybe what it does is maybe it just touches tangent on each part. Who knows for sure? And the only way we'll really know for sure is if we find the points of intersection. Do you remember how to find the intersection between two graphs? Your calculator does. And if you weren't given a calculator, what would you do? Set them equal to each other. X to the fourth is equal to 2x squared minus 1. And all of a sudden, we've taken what looks like a very challenging situation. We made it quite easy. Put them all on one side, so says Marissa, and she is correct. Minus 2x squared plus 1 is equal to 0. Anybody have a grand idea now? Factor. So this is going to be x squared minus 1, and x squared minus 1 is equal to 0. So it's kind of interesting here. How many solutions do we have? We have 2. We have 4 solutions, but 2 of them are double solutions, right? And a double solution means that it touches tangent. So it touches tangent at that spot. Does it look like that x value might be approximately positive 1? And the other side would be negative 1? Yeah. Yeah, it would touch tangent. You could confirm that on your calculator, but that's the way this part works out. Okay. And so the integral, no big deal as we set this up. Remember, as we try to draw these, I'm going to draw a rectangle. Okay, a rectangle. That's one rectangle that represents area between the top and the bottom. Does that rectangle have horizontal thickness or vertical thickness? Horizontal, so therefore it is dx. The height is the top function minus the bottom function. Which one's on top? X to the fourth. Minus the bottom function, which is 2x squared minus 1. So that is the area of one rectangle. How many rectangles do you want? You want an infinite number, so you slap on an integral sign. That goes from 0 to an infinite right away, which is pretty cool. Negative 1 to 1. So here's the point where it's that part of, are you paying attention, or are you just kind of halfway in and out? So for those of you who are fully paying attention, this is what's going to save you time. I never do the problem like that, okay? I set it up like that, but I like to save myself time. And I noticed something. I want you to talk to your peer next to you and say something that you notice about this graph. See if you guys can pick up on it. Talk about something you noticed with the graph. Go, talk. Okay, anybody notice something interesting about the graphs? Marissa says she notices something.
Down 1, so instead of the intersection being at 0, it's moved 1 to each side.
Okay, we do have one to each side. Yep. Tim? There's some negative area. We say that, so that's interesting. When we say area between two curves, we say that that is always positive. You're right, if it sits below the x-axis as a single function, we always call that negative. But if it's between two functions, we always reference that as positive. It would come up negative if you did bottom minus top. That would come up negative. Did you notice that these two functions, that they are symmetrical? Did you notice that the area, and this is the important part to lean in on, did you notice that the area in the green that I'm shading right now is the same as the area in the blue? And so what I like to do is I like to not integrate from -1 to 1. I like to integrate from 0 to 1 and double the result. Because when I plug in 0, I'm less likely to make a mistake. Now, ahead of time, you have to recognize that they are symmetrical. See the difference? So if you do produce the graph, and that's often when people are like, do I have to make the graph? I guess I've been doing this a long time. I think it's helpful to look at the graph. So I guess it's up to you, but I like making the graph. I can see it's symmetrical. I'm going to double the area from 0 to 1 of x to the 4th minus 2x squared plus 1 dx. That's the integral. On your test, I will have multiple types of problems. One problem will be where you evaluate the integral by hand, and you come up with a numerical result. I will have other problems where I just ask you to set up the integral and don't worry about evaluating it. You know what I mean? In that case, I would accept either one. But producing the accurate integral is always required of you. Get that? And then finally, the last type of problem I would ask you would be a calculator type question, which we'll look at here in a second. So let's evaluate this. Okay? Antiderivative. X to the 5th over 5 minus 2x to the 3rd over 3. And isn't that great? We got rid of the -1 by doubling it. That's going to make it super simple. 2 times, we plug in the 1 and we get 1 over 5 plus 1. This is a pretty nice problem. I would say this is one I would definitely ask you to do by hand. Nothing wrong with it. We got 2 times 3/15 minus 10/15 plus 15/15. And I learned how to do this a while ago. 3 minus 10 is -7, and -7 plus 15 is 8. Times 2 is 16/15. That's pretty cool that you found that exact area between those two curves that quickly. It does come out to be exactly 16/15. Not too bad? Okay. Flip it over. Talk with the person next to you. What makes this problem different than the others we've looked at? I will not draw any of it. Talk to your peer. What makes this one different than the other ones? Talk. Go. Okay, I heard a lot of people make that suggestion. What did they say?
It's not equal to x. It's equal to x.
Yeah, we got 1 equal to y. We got 1 equal to x. What did I do? Why? Okay, I'm getting the biggest laugh from her right now. And all I can think of is I really like your hair today. Isn't it great? I love it. Yay, way to go. Okay, now tell me what you're laughing about. Okay, do I have a booger? Is it the finger? Did I tell you I put my finger in his... Oh yeah, I was doing dishes yesterday. And, you know, because I know better than everybody else, I just went ahead and put all the knives and everything in there. Wash all the knives, everything's fine, but I put the dicer in there. You guys have one of those dicers where you pull the top, you like dice up an onion? So I didn't want to grab the grid part. And so I didn't grab the grid part, but I didn't realize that the dicer we have is also a slicer. Why is this funny? So I went to grab it and also went, ah! Like, what? I pulled my finger up. It's like there's blood everywhere. I was on the phone with Mr. Luther. I'm like, I can't talk anymore. I said, I maybe lost the tip of my finger. It's really bad.
When I commit a crime, you use that figure now.
Why does it have to be a crime? Oh, I got it.
Fingerprint.
Okay, that's a famous scene in a movie where somebody tries to identify the killer, but they've sanded off all their fingertips and they can't identify him. Yeah, yeah. I got all sorts of great movies for you guys to watch sometime.
You know what we should do? We should watch movies.
Yeah, we should watch movies because we can't do that at home. All right.
Oh, no. We'll do that after. It's so good.
All right. This was equal to y. This was equal to x. And that will create a little bit of a problem. And sometimes you have two options. In this situation, you just have one. And the first thing you do is you have to sketch the graph correctly. I'm going to start with this one. And notice, if I would factor it to x is equal to y minus 1 times y, that instead of having x-intercepts of 0 and 1, it has y-intercepts of 0 and 1. Okay?
Wait, Mr. Guy,
Yes.
can you not just make it so it will y?
No. How would you do that?
Or you would add the y to the other side and correct it.
Okay, got it. So we're going to add the y to the other side. We'll get y is equal to y squared minus x. Now you're okay? No, that's a problem. If you guys remember, last year we learned about sketching these things. This is a sideways parabola. And so yep, exactly. So it's going to head off to the right. It's going to have this shape. That's the first thing that you have to see. Okay? So y squared minus y is a parabola that goes to the right, has intercepts of 0 and 1. Marissa, it is your turn to speak.
So why isn't the never mind.
Okay. Then the next one we have is we have 2x minus 2. Everybody knows that that's a line that has a y-intercept of negative 2. And it looks like this. Okay. So I always told you top minus bottom. Watch what happens if you do the top minus bottom. If I do top minus bottom and I draw a rectangle right here, what's on top, the parabola or the line? The line. Or the parabola's on top and the line's on the bottom, right? Now watch what happens. If I draw the rectangle here, the parabola is still on top, but what's on the bottom? The parabola again. If you took the parabola minus the parabola, it would just disappear, right? So top minus bottom does not work in this situation. And what you will have to recognize on the test and on the AP exam is that in this situation, you don't draw a top to bottom rectangle, you draw a right to left rectangle. So now, do we have horizontal thickness or do we have vertical thickness? For vertical thickness, so therefore this is a dy situation. So that means that all of the variables need to have a y in it and not an x. So the y squared minus y, that's fine because it has your y's in it. This is not okay. So I want to go ahead and solve here. So I'm going to solve for x. So I'll take y plus 2 is equal to 2x. And I'll divide by 2 to get 1/2 y plus 1 is equal to x. So now they are both an x equals, therefore y is the variable. Okay, see that now? Okay, which one is on, instead top minus bottom, it's now going to be right minus left. Which one's on the right? The line. So I have 1/2 y plus 1 minus what's on the left? Y squared minus y. That's the area of one rectangle, but I don't want one rectangle, I want, so slap on the integral. And now I need to come up with my bounds. How do we produce bounds? We set them equal to each other, yep. So I have 1/2 y plus 1 is equal to y squared minus y. All on one side. So I will get 0 equals y squared minus, what's 1/2 y minus a negative, or I'm sorry, negative y minus a 1/2 y. Anybody? Negative 3/2 y, good. Minus 1. I don't like factoring it if it has a fraction in it. Since it's set equal to 0, I could multiply through by,
2/3.
or just 2. If we multiply through by 2, everybody see how the fraction will go away? And it's great to multiply through by 2 because 0 times 2 is still 0. So I have 0 equals 2y squared minus 3y minus 2. That looks like something that could maybe factor, right? So 0 equals y minus, I'm sorry, 2y and y. Any thoughts? Plus 1 minus 2. Yeah, that works for us, doesn't it? So therefore, we have y values of intersection of 2 and negative 1/2. Let's look back at our drawing. Does it look reasonable? Understand that because it's dy, your variables also have to be y variables. Does it look like we might have an intersection of y equals negative 1/2? Yeah, and does it look like it might be y equals positive 2? Yeah, that one's not as convincing, but it looks reasonable with our drawing. So sure enough, we have negative 1/2, and we have positive 2.
So, if our drawing looks really bad, will you take a punch up for that?
Nope. No, I have to, and the drawings are going to become a little bit more complex as we move on. But I just want to be clear that I use your drawing to try to just understand what you're trying to do with your result. Because sometimes it really does matter. Okay. All right. So let's integrate here. We have the integral from negative 1/2 to 2 of, and let's combine some of these things together. We'll have a negative y squared or positive y squared. Negative y squared. I have a 1/2 y minus a negative y. Positive 3/2 y. And then I have a positive 1. So we need our antiderivative.
So you found out it was a horizontal rectangle because of the y equals?
That's correct.
It has y equals in the thing?
Yes. Antiderivative. Plus, yes, thank you, 3y squared over 4 plus y, evaluated at 2 and negative 1/2. Plug in 2. What do we get? Negative 8/3. 2 squared is, divided by 4 is 1 times 3 is. That worked out pretty good, didn't it? Now I got to plug in the fraction. Yeah. Negative 1/2 cubed. Yeah, so you get negative 1/8 times the negative would be positive 1/8 divided by 3. 1/24. Plug in negative 1/2, negative 1/2 squared. 1/4. 1/4 divided by 4 is 1/16. So you get 3/16. And then we get a minus 1/2. Okay. Can we just plug it in our calculator?
Yep.
Okay,
Yeah.
we'll go there. So this is one I would not have you do this by hand, just to let you know kind of my expectation. So in case you didn't know this, you could do -8/3 plus 3 plus 2 parentheses minus parentheses 1 over 24 plus 3 over 16 minus 1 over 2. And when you press enter, if you don't like that decimal, go ahead and press math and enter on convert to fraction. It'll put it as 125 over 48.
Would you put math?
Enter on convert to fraction.
Sometimes it doesn't make a fraction.
Okay, so yes, let's take that point because you make an excellent point. Suppose you have the square root of 2, and then you say, hey, I'd like to convert that to a rational number. This is an irrational number. It cannot be represented as a rational number. So if you go express as a fraction, it says, I don't like that idea. So it does, it has those limitations. Okay, take out your calculator. It's our last part for today. And we are only going to look at part A. We're only going to look at part A. I saw her too.
Oh my god.
Yeah. She had a like super straight hair look going on today. Yeah, yeah.
And I walked in the door and I talked about the.
I was going to tell her that Kendall should cut her hair half the length and they could like twin on a given day.
So sick.
Yeah.
I like the same clothes.
Mr. Good.
No, I'm done with you. You call me Mr. Luther again. I'm totally stronger and better looking and smarter than he is.
Mr. Luther, say good, second Luther.
Don't care.
Remember how we did
No, I don't remember.
it? Well, everyone else read it.
Yeah, I know. I remember that. It was when we started in class. Okay. What I want you to do is I want you to look at this picture. We're only going to do letter A. And I first want you to look at these two curves. And we have f of x is the top one and g of x is the bottom one. See if you can plug it into your calculator and adjust your window so you get about that picture. Plug it into your calculator and try to get about that picture. Go ahead and see what you come up with. Oh, you got that one. Okay. You know what song I have in my head? BK, have it your way. You rule.
Is that the one?
Yes. BK, have it your way. You rule. Whopper, 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 chicken, whopper, fish, chicken, whopper.
Matter of fact, I mean, that two plain don't either. Yeah. Matter of fact, make that two. You won't look at it.
Okay, everybody pause and look up here. Do you at least have these two functions? So if you want to try to get this region right here, I think one of the best options to do is zoom as a box. Kind of embarrassed. My daughter's a senior at Owatonna, and I was doing some math with her the other night, and she didn't know that the zoom box was an option. And I was embarrassed, not because of their teacher, but more because I'm her dad, and that should have been something I taught her. So, but anyway, so I press enter here, and I go down and press, go over, and hopefully I will get that type of a look. And it looks like that's the sine curve, so I'm seeing this part, good. And then I'm getting that part underneath. Cool, great. So let's look at, everybody got that about that graph?
Yeah.
Great. So it says for part A, and we're just going to do part A, it says find the area of region R. Well, how would we find the area of region R? What would you do? Good, excellent. So Michaela says take the top function, which is f of x, and minus the bottom function, which is g of x. Okay? That's a great idea. Everybody good with that?
Yeah.
And so, and then dx, because that's it's a vertical, or it's a horizontal width, right? Vertical rectangle, horizontal width. So all we need now is what? The bounds. How would we use our calculator to find the bounds? So we're going to go second calculate, and which one are we going to grab? Number 5, intersection. And I'm going to go close to the point of intersection, and I'm going to press enter, enter, enter. And I'm going to call that point B, okay? So I'm going to go over here, and I'm going to make a label, and the AP exam allows you to do this. I'm going to say that B is equal to 1.1356925. And then I'm going to find A, and A is the other intersection point, and I'm going to go second calculate, number 5. I now need to mosey on over to the other side. And some of you recognize by the setup of the problem exactly what the value is.
That's got I got 1.612 negative. That's
Zero.
So you see that, yep, that would be 0. See how it's just right at the x-axis?
We just call it 0.
Yes, not just 0, but exactly 0. Your calculator is an estimation. We're exact. Okay.
Yeah, why would you estimate negative 13? Just call it 0. Like square it to negative 13.
Excellent point, my friend. So we're going to go from 0 to B. So the AP exam does not require that you write down the function every time or that you rewrite this point of intersection every time. Just go from 0 to B of f of x minus g of x. And the AP exam says that's absolutely fine. Everybody okay with that? So now let's actually calculate it. And I've tried to teach you this before. We will go into our y equals. And I want to do the top one minus the bottom one, right? So what I'm going to do to try to save some time, anybody know what I'm going to do? Yeah, I'm going to go into my variables, my y variables, and I'm going to grab y1. And I will subtract from my variables, my y variables, I will subtract y2. And notice how I only have that one highlighted. So it's only going to produce that. I will calculate which number? Number 7. Notice how it goes through 0, and then the other spot it should go through is my 1.13, which it does. And so my lower limit is 0, and my upper limit is 1.1356925. And I get 0.429. The AP exam asks that we write it to 3 decimal places. And just to give you an idea, if you did that much on the AP exam, that would be worth 3 points. You would get 1 point for finding the intersection. You would get 1 point for writing the correct integral. And you would get 1 point for the answer. And out of 9, generally, nationwide, the average score on the 3 responses is 3 out of 9. And that alone would give you those 3. I think that that's very reasonable to expect, don't you? Yeah, so it's not like everything's impossible. Whether or not you remember it, that's a whole other story. So go ahead, take out your homework. You are now able to work through the rest of your homework, but you would start with 3 and 4. And to be clear, for 3 and 4, you're not drawing vertical rectangles, you're drawing horizontal rectangles. These are going to be dy. As you look at the bounds, okay, what is the lowest y value for my bounds? What's 0, and what's the highest y value? 1. Now look at over here. What's the lowest y value for my bound? 0. What's the highest y value for my bound? 3. So these two will be a right minus left situation. Okay, right minus left. Okay. I will shut off my mic and then I will help Mr. Easton